Next up is logical and tautological consequence. Well, just in case you thought you'd never see your beloved truth tables again, here's another use for them. We can use truth tables to determine what is a tautological consequence. Now, a logical consequence is where if one sentence is true, the other one has to be true. And in a tautological consequence, if one sentence, say B, has a T in the truth table, in the same row, its consequent A must have a T. It cannot have an F. Let's see this in action using our truth tables. So here are two antecedent sentences. I've kept the color coding for antecedents and consequence. So these are our antecedents, and this is our consequent. And we can put these in a truth table in order to see whether this is a tautological consequence. The first is a disjunct, so it comes out true whenever one of its disjuncts is true. The second is a negation, so we just flip the values in the left-hand column. And for B, we can just repeat the values as they appear on the left. And then it's just a matter of running down the rows. So, assuming all the antecedents are true, the consequent must be true. Well, the consequent is true here, and anyway, one of the antecedents is false, so that's all right. The consequent is false here, but then so is one of the antecedents, namely not A, so that's okay as well. In the third row, they're all true, and so that's okay. And in the fourth row, the first antecedent is false, so it doesn't matter that the consequent is false. So since we never go from all T's to F's on any row, this is a tautological consequence. Now there are logical consequences that are not tautological. Here's an example of one that we've already proved earlier. Again, we'll color the antecedents yellow on the left-hand side here, and the consequent blue, and we'll drop these into a truth table. Now because they have no logical connectives, these will just carry over to here like this in terms of their truth values. So we can compare them in the columns without writing them out underneath, because if we wrote them out underneath, they'd all be the same. All right, in the first, they're all true, and so that's fine. But in the second, notice the antecedents are true, but the consequent is false. And we only need one of these to know that it's not a tautological consequence. The rest doesn't really matter. This one here tells us that this is not a tautological consequence. It is, however, a logical consequence. If A equals B and B equals C, then A certainly equals C. But it's not a matter of the form of the sentences, because equals is not one of our formal truth functional logical operators at all. It's, as you'll recall, a special sort of predicate. So although this argument is a logically valid argument, it is a logical consequence, those two ways of describing it just being synonymous, it's not a tautological consequence because it doesn't have the appropriate arrangement of T's and F's in its truth table. And that's how we can show that something is a tautological consequence and also show that it's not. But just bear in mind that although every tautological consequence is a logical consequence, not every logical consequence is a tautological consequence, and so showing that something is not a tautological consequence with a truth table does not mean it's not logically valid.